So example one. Example one says, state the bearing indicated. State the bearing indicated in each diagram. The first answer is already given. All right, let's go to our diagrams. All right, so the bearing here is 47 degrees. What we are being asked to do is to state what bearing that is. All right, what do I see in the diagram? I have what? The points P, Q, and R. At P, I have my north-south line, my north-south, east-west lines at P. I have a line connecting P and Q. The angle there starts from north and come around to the line connecting P and Q. Guys, the angle 47 degrees, 0, 4, 7 degrees is the bearing of Q from P. How do I know it's from P? Wherever I'm taking the bearing from, that is where you draw your north, south, east, west line is drawn. The arc stops at the line connecting P and Q. So therefore, the angle, which is 47 degrees, is the bearing of Q from P. Why? Why Q? Because the arc goes from north and come around to the line connecting P and Q. The north-south line is drawn at P. This 47 degrees is the bearing of Q from P. What I want you to do now is to identify in a similar fashion what are the other bearings. Give me the answer for II and triple I. You can type your answer in the chat. All right, in II, the arc from north comes around and stops at the line connecting P and R. The arc from north, it starts from north and it comes around to the line connecting P and R. So I know the bearing here, the 104 degrees, that bearing must involve P and R. Why? Because the arc starts at north and it comes around to the line connecting P and R. Since the north-south line is at P, it means I'm taking the bearing from P. So the 104 degrees is the bearing of R from P. I know it is from P because the north-south line is at P. In II, the north-south line is at Q. So I know I'm taking the bearing from Q. Now the arc starts at north and come around to the line that connects Q and R. So I know that the bearing involves Q and R. Since the north-south line is at Q, I know that I'm taking the bearing from Q. So this 146 degrees is the bearing of R from Q. All right. Do these two very quickly. Type your answers in the chat. All right, so IV, notice that the arc from north comes around and and stops at the line connecting P and Q. So this bearing must involve P and Q. So since the north-south line is at Q, the 228 degrees is the bearing of P from Q. For V, the arc stops at the line connecting R and P. The north-south line is at R. So the 284 degrees is the bearing of P from R. Lastly, or I think it's the last one, the line here, the arc goes all the way around and stops at the line connecting what? Q and R. The north-south line is at R, so I'm taking the bearing from R. So this 325 degrees. Is the bearing of Q from R. All right, example 2. All right, so I have example 2 and in bracket, I guess I'm reminding myself, should be done by the teacher. So the next thing that I think we could have done a little bit more, but at least we learn how to interpret a bearing diagram. So example 2 and I have in bracket should be done by the teacher. So let me go ahead. This says 3 landmarks P, Q, and R are so located that the bearing of Q from P is 70 degrees. The shortest distance between P and Q is 60 kilometers. The bearing, I'm going to draw the diagram. It says in the space provided immediately below, sketch a diagram of the information and clearly show the north direction, the bearings 70 degrees and 135 degrees. And I'm guessing we should put in the length of the site as well. So 3 landmarks P, Q, and R are so located that the bearing of Q from P is 70 degrees. And then the bearing of R from Q is 135 degrees. All right, I have a mental appreciation of this now. All right, so I have a starting point. My starting point is P. And I'm told that the bearing of P of Q from P is 70 degrees. So at P, I'm going to draw my north, south, east, west line. Because I'm taking the bearing of Q from P. So this is my north, south, east, west line, and this is the point P. Now the bearing of, so this is north, bearing is measured clockwise from north. 70 degrees would put me somewhere in this direction. So the bearing of the bearing of Q from P is 70 degrees. So the angle here is 70 degrees. Zero, 7, 0 degrees. And this is the point Q. So if you look carefully, you can easily interpret this for yourself. The north-south line is at P, indicating I'm taking my bearing from P. The arc stops at the line connecting what? P and Q. So the bearing here must involve P and Q. So that 70 degrees is the bearing of what? Is the bearing of Q from P. Then we're told that the what? The shortest distance between P and Q is 60 kilometers. Now, the shortest distance between 2 points is a straight line. So it means that this length here is 60 kilometers. Stay with me. Next, we're told that the bearing of R from Q is 135 degrees. The bearing of R from Q the bearing of R from Q is 135 degrees. So I'm taking my bearing from Q. So at Q, I'm going to draw my north, south, east, west line. North. So let's put in the east-west line as well. And the angle is 135 degrees. Between north and east is 90 degrees. So 135 degrees must be between east and south. So 135 degrees would put me in this direction. And we're told that what? The distance between them is 90 kilometers. So this is R, and this distance is 90 kilometers. And if I want, I could complete my triangle by connecting R back to P. So if I wanted to, and I'm being picky, I guess I could give a nice straight line here. All right, this is R, and this is 90 kilometers. All right, and if I want, I could do the same thing upside. The angle here is 135 degrees. So that is the information that I was given. I was told that the bearing of Q from P is 70 degrees, and the straight line distance between Q and P is 60 kilometers. I was told that the bearing of R from Q is 135 degrees, and that the distance between them is 90 kilometers. This is the information that I was given, being represented as a diagram. Next, I'm asked to calculate the nearest whole number, the size of angle PQR. We're asked to calculate to the nearest whole number the size of angle PQR. Now, this is angle PQR. That's angle PQR. Whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. That is the angle PQR. The easiest way to find this is to divide it into 2 pieces. So I'm going to divide it into two pieces, call this piece alpha and call this piece theta. All right, so we're asked to calculate the size of angle P, QR. I divided it up in two pieces, alpha and theta. So to get the angle, I have to first find alpha and find theta and then add them together. Looking at my diagram, I can see that alpha is equal to 70 degrees. They are alternate angles. And that theta is equal to 180 minus 135 degrees. And this is because they are angles on a straight line. So these two angles are angles on a straight line. Angles on a straight line add up to 180. So I simply just what? Take away 135 from 180 to get theta. That theta is 45 degrees. Alpha and 70 degrees, you can see it, they're alternate angles. Alpha and the 70 degrees, they are alternate angles. Alternate angles are sometimes called Z angles. All right, so I can now say that angle PQR is equal to 70 plus 45. This looks like 115 degrees. So this is 115 degrees. All right, let's see what we're asked next. Next, we're asked to calculate the straight line distance between P and R. Calculate the straight line distance between P and R. And guys, if you look at the triangle now, triangle P, Q, and R. If we look at the triangle now, you'll notice that this is a non-right angle triangle in which I know the length of two sides and the inclusive angle. Guys, if you know the length of two sides of a non-right angle triangle and the inclusive angle between them, and you want to find the length of the third side, you're going to use the cosine rule. I need to use the cosine rule to find x. So applying the cosine rule, I'm going to say a square is equal to b square plus c square minus 2bc cosine a. A is the side opposite the inclusive angle, which is x, so x squared. The other two sides are what, 60 and 90. So 60 squared plus 90 squared minus 2 times 60 times 90. The cosine of the angle between them, which is 115 degrees. Do not let the big numbers scare you. Just work the thing like how you would normally work it. All right, so we have 60 squared. This is 3, 6, 0, 0, 90 squared. It's 1, 0, 0 minus 2 times 60. times 90. This is 10,000 800. The cosine of 115 degrees. This is plus 8100, 11,700 minus 10,800 cosine 115 degrees. So 11,700 minus 10,800 cosine 115, press equal, and what you get is 16,264.3. And that is x squared. The opposite of square, x, which is PR, is the square root of this. 16,264.3, and this is equal to 127.5, and I think they asked us for to the nearest whole number. It's 128 kilometers. The distance between P and R is 128 kilometers. So this distance is 128 kilometers. Last thing we're asked to determine the bearing of P from R. Lastly, we are asked to determine the bearing of P from R. So let's put that in our diagram, the bearing of P from R. So since I'm taking the bearing from R, at R, I'm going to draw my north, south, east, west line. All right, so this is R. Now, I want the bearing of P from R. So that angle must start at north, and it's going to come around all the way around and stop at the line that connects P and R. I need that angle. All right, so we need to find that angle. Now, pieces of this angle we already know. From north coming all the way around to west is 270 degrees. This is the piece that we don't know. Let's call it beta. That's the piece we don't know. And in order to get our answer, we need to find out what that angle is. So our answer is going to be 270 degrees plus whatever that little piece is. That little piece is the problem, and we need to find out a way to find it. And that is your job now to see, well, how you going to find that angle. It's actually doable. To find it, we have to first find this angle. Let's call this angle gamma. Now, we just use cosine rule on this triangle. So this is what I think I told Perseus. After you use cosine rule on a triangle, the next rule you must use on a triangle is the sine rule. Now, we're going to find this angle, and we need this angle as well. let's call it something. Let's call it rho. We need those two angles. Then to get our answer, we're going to add those two angles and take it away from 360 degrees. To get our answer, we're going to add those two angles and take it away from 360 degrees. Guys, to find gamma, which is the one inside the triangle, we're going to use the sine rule. So it's sine gamma over 60 is equal to sine 115 degrees over 126. So this is going to be sine gamma over 60 is equal to sine 115 degrees over 128. Not 126, it's 128. Carry 60 up here. I'm going to have sine gamma is equal to 60, the sine of 115 degrees over 126. 128. Put this in my calculator and press equal. I need 3 decimal places. So this is 60 sine 115 divide by 128 to 3 decimal places. This is 0.425. So gamma is equal to sine inverse 0.425. Gamma is equal to this is equal to 25 degrees. That is equal to 25 degrees. All right. And coming back to here, we can see that rho, whatever this is, which is 45, this angle is also 45 because they are alternate angles. All right, remember we needed rho in order to get our answer. Rho is 45 degrees because it and the theta are alternate angles. You could use alternate angles or you could use co-interior angles. Rho and the 135 degrees are co-interior angles. So let's use that. I'm going to say rho is equal to 180 minus 135 degrees. It's 45 degrees. They are co-interior angles. All right, so it means therefore that the bearing of P from R is equal to 360 minus 25 degrees plus 45 degrees. That's what, 70. It's 360 minus 70. The answer is 290 degrees. The bearing of P from R is 290